Hi, my name is Leo Zhadnovsky, and I'm a Principal Solutions Architect here at AWS, and today we're going to be talking about dev and test on AWS. So thank you for coming, and generally our customers go through a journey through the cloud, and so we're going to talk about how that applies to dev and test. So we're going to talk about some common use cases and adoption models for the AWS Cloud. We're also going to be talking about learning from journeys other customers have taken, and discovering best practices out of those journeys that you can use to bootstrap your projects and your dev and test workloads on AWS. So we're also going to be talking about exploring the benefits of AWS with a non-production use case, so things that aren't live in front of customers. And we're going to talk about how to create agility and elasticity in your dev and test environments, and using this also as a lesson to learn about our services so you can eventually use these lessons you learn for your production workloads as well. We're also going to be talking about how to take advantage of AWS services to enable you to do automation so that you can scale your dev and test workloads on AWS. So the agenda for today, first we're going to talk about why AWS is a good choice for your development and test workloads. We're going to be talking about which specific AWS services you can use to support your dev and test workloads. And then we're going to cover some common dev and test patterns. So we'll talk about different services such as CloudFormation, Code Build, and EC2, VPC, and how these all fit together to allow you to do dev and test on AWS. And we'll point you towards some resources where you can continue to learn about this topic. So the first section is why AWS for development and test workloads. Well, so there's some common traits of dev and test workloads, and they fit really well with AWS strengths. So dev and test workloads are typically disposable, so it's not like a permanent infrastructure that you have up and running. Basically, you might have different software products, different projects, different environments, and they're going to come up and down. So it's not something that's always statically there. And there's going to be numerous environments, right? So you're going to have something like staging and dev and test, and you might have one of these environments for a bunch of different apps. You might have one of these environments for a bunch of different features you're developing for the same app. So you have to be able to spin up a bunch of these environments very quickly and also tear them down very quickly so you don't incur unnecessary costs. So again, projects, they stop and start really frequently. They're often required for a short period of time, and you want to have gold masters prepared for them. And so what that means is instead of having to start over again and creating your dev and test environments, you want to be able to spin up an environment that follows your best practices and has images which are pre-configured with whatever software and packages you need to do your dev and test. And you want to be able to do that quickly instead of having to manually do it every single time you spin up an environment. Now, as I mentioned earlier, one app can have many environments. It can have a staging environment, beta environment, alpha environment, so on and so forth. You want to be able to preserve known configurations for each of these environments. So, for example, in your testing environment, you might want to have smaller instance sizes, and you might want to have a certain number of instances. And when you go staging, you might want to have the same type of instances as you have in production. You might want to scale up and have more instances. So being able to keep track of what configuration do I need in which environment is pretty important. So these two things come together, and doing these in the cloud is actually really easy. So AWS allows you to deploy your infrastructure as code. So what that means is, aside from just the configuration state or just the general state of your operating system, you can also define the state of your whole infrastructure. So your load balancers, your databases, your app servers, any kind of caches, any other resources that your environment's going to have, instead of having to manually spin those up, you can define those as code and deploy to a known state very fast. AWS offers you unlimited elastic capacity. So when you need to do, for example, a load test that involves hundreds or thousands of parallel instances that you can use to generate load with, you can take that capacity, but you don't need to provision for the peak capacity that you need. So you can spin up 1,000 instances, do a load test, and then turn them off, and only pay for what you use. And EC2 is charged by the second, so you won't pay for a second more of the capacity than you use, as long as you shut your resources down as soon as you're done with it. So we also have an on-demand charging model. So again, you have unlimited capacity, and as I mentioned earlier, you spin up capacity when you need it, and you turn it off when you don't. And lastly, you have access to durable storage. So whether it's S3, which is our object store, or EBS, which is our block store, or EFS, which is a persistent shared NFS compatible file storage service, you can preserve the results of your environments and your tests and so on and so forth for future use while turning off the compute part of those environments. So let's talk about AWS services that are essential to doing dev and test workloads. So first of all, EC2 and VPC. So EC2 is our virtual server service, and VPC is basically the software-defined networking component of EC2, and other services such as RDS, Redshift, Elasticache also run on top of VPC. So EC2 is what you use to spin up virtual servers, and it also gives you features such as AMIs, so Amazon Machine Images. So you can define a gold master image that you use to spin up your environments. You can then take snapshots of your volumes and your images. So once you take a snapshot, then you have essentially a backup of that image or of that volume, and you can bring it back at any time you want. And you can also configure bootstrapping with EC2. So instead of spinning up a blank instance all the time, you can have it bootstrap itself with your latest code or your latest packages or software that it needs. We also have a service called Elastic Beanstalk. So Elastic Beanstalk handles the deployment of things like load balancers and databases and web servers for you, and basically gives you a application container that you can then deploy into without having to worry about all the undifferentiated heavy lifting associated with setting up all the rest of the infrastructure that you need for that app. And then lastly, we have CloudFormation. So CloudFormation allows you to define your infrastructure as code. So you write a file, that file can be in JSON or YAML, and that defines your whole infrastructure. So again, your load balancers, your application servers, your web servers, your databases, and you can then use that template file to actually deploy your infrastructure, to update it. You can store it in version control as if it was code. So this is, again, just a description of what these services do. And so let's take a look at, for example, how to build a golden image. So you take a generic Amazon Machine Image. So we give you a bunch of images that we provide for you. So if you're using Amazon Linux or if you're using Windows AMIs, we provide those AMIs for you. We also have partner AMIs. So for example, if you're spinning up CentOS or Ubuntu, that's provided by those vendors. So you pick whatever machine image that you're using. You spin it up in an instance. You then load your application stack onto that image, customize it as you see fit, and you make a new customized AMI off of that image. So then when you spin up your dev and test environment, instead of having to do this process all over again, you just spin up the customized AMI that you've created, and it's all ready to go, and you've saved yourself a lot of repeatable work there. Let's talk about VPC. So again, VPC is a software-defined network that you use, that EC2, that Redshift, that RDS, that a bunch of other services run on top of, and allows you to do things like define your subnets, control who can what can talk to different instances, different subnets. Or as an example here is, you can extend your on-premise environment into AWS. So you've got your VPC in an AWS region, you've got your on-premise data center, let's say in a co-location space, and you've got your instances running in the VPC. And what you can do is you can set up a connection, whether it's a VPN connection or a direct connection, Direct Connect, which is a service that we have that gives you a national fiber connection between your data center and your AWS infrastructure. And you can have a secure channel of communication across those. So for example, if you're using a VPN, you set up a VPN tunnel, the way you set up it's redundant, it's encrypted in transit, and now you can talk to resources in your data center. So for example, if you have a Git repo that's in your data center, but you need to access it from your dev and test environment, once you have the VPN connection set up between your on-premise environment and your VPC, you can now access that. So let's take a look at Elastic Beanstalk. So in this example, I have two environments in my Elastic Beanstalk app. I have a test environment and I have a production environment. My test environment has smaller instances because it's not getting as much load as my production environment, and it's got a smaller auto-scaling group. So it doesn't use many instances. It is a single AZ because again it's a test environment, it doesn't need to be on multiple AZs, and it talks to a different database than the production environment. So what Elastic Beanstalk does is it handles deploying my application to that environment. So I can deploy it to my test environment. I can then make sure that the deployment's okay, the app's functioning as intended. Then when it's done, I can deploy to my production environment, and it handles all the underlying heavy lifting of that. So Elastic Beanstalk also supports a bunch of different container types. So you can do PHP apps, Ruby apps, Java apps, Node.js apps. You can have a Windows container. You can have Docker containers too, and also customized environments. So it's very flexible on what you can actually deploy with it. So now let's take a look at infrastructure as code. So with CloudFormation, again, you have a CloudFormation template, and that template defines your whole infrastructure. So in this case, we have a multi-AZ RDS instance. We have an auto-scaling group of EC2 instances, which serves our web servers, and we have a load balancer, and you'll be in front of it. And so when you go to your website here, you hit the load balancer, that redirects you to one of the underlying instances in the auto-scaling group, and the instances talk to the MySQL RDS instance where the database is stored. So anyway, instead of having to set up all these components independently, you can define these all in one CloudFormation template and deploy them out of the template. So just to summarize, for CloudFormation, it gives you several features that are super useful. First of all, it's a procedural definition of your environment. So it's created programmatically. So it's a file that you can reference, and it's going to create the same environment every time. So if you deploy the CloudFormation template 10 times, there's no chance of like manually typing it in a wrong command or anything, as you would when you're manually setting up an environment. It's all created programmatically. It's parameter driven, so you can put parameters in a CloudFormation template, so you can reuse the same template for different environments. So for example, if I have a parameter for the number of instances in my auto-scaling group, or the size of instances, I can have smaller instances in a smaller auto-scaling group in my dev environment, and I can have a larger instance type and more instances in my prod environment, but yet still use the same template for both of them. It is a known configuration, so if you store your CloudFormation template in a version control repo, such as a Git repo, you can keep track of your infrastructure just like you keep track of your application code. And so you can roll back, for example, to an old template if you need to. And lastly, because it's a text file that you can share, it's easy to collaborate. You can send another team a copy of your CloudFormation template. You can post it online if it's a public template. So it's really easy to get quickly reproducible environments that you can share with others on your team. So to find out more, go to the CloudFormation website, or webpage that we have at aws.amazon.com/CloudFormation. So let's talk about some common dev and test patterns. So first of all, you probably want to store your source code in some kind of version control system. Among our developers, among our developer community, we see that Git is pretty popular, and there's multiple options for that. So you can use our service, which is called Code Commit. It's part of our code suite of services, or you can use a third-party service such as GitHub. For project management, we have a AWS Marketplace where you can get third-party tools, and so For that, you can use something like a Jira, for example, and spin one up off of our marketplace. If you need a managed solution for developer workstations, so that they don't have to set up, when you have a new developer, you don't have to spend time setting up a work development environment for them, you can use our workspace service, which gives them a managed Windows desktop. And to spin up continuous integration or build servers, you can either put something like Jenkins on an EC2 instance, or you can use our AWS Code Build service, specifically for building, and you can use Code Pipeline for continuous delivery. So let's take a look at a common pattern that we see on AWS. So for example, here I have a project management service, such as Jira, that's running on an EC2 instance. It's probably talking to database and RDS. I have a continuous integration server, such as Jenkins, that's also running an EC2 instance. I have a source code repository, so let's say I have a Git running, that's also running an EC2 instance, and the actual Git repo is stored on EBS volumes, so it's on persistent volumes. And my builds that are generated by my CI server are then also stored in S3, where they can get deployed by something like Elastic Beanstalk. Now, that's all assuming you're using self-managed services. If you're using our code suite of services, you can actually replace the CI server and the builds with code build and code pipeline. You can replace the source code repository with code commit, and then a lot of this will be managed for you. So again, our marketplace, there's a lot of solutions on there. So for example, you could easily deploy Jenkins or Redmine in a few minutes from our marketplace. And if you want to easily recreatable dev and test environment, and once you define what your dev and test environment is, you can write a CloudFormation template for it, and you can spin it up off of that CloudFormation template. Another thing that you can also do is actually have your CI/CD set up, so whether it's something like Jenkins or whether it's a code pipeline, you can actually have it deploy your CloudFormation template just like you deploy your code. So you have a new version of your infrastructure, and it gets automatically deployed by your CI/CD pipeline. So now let's talk about testing at scale. So there's different kinds of testing. There's unit and regression testing. There's A/B testing, where you're testing which version of your app performs better. There's load and performance testing, so where you see how your application performs and how it actually, how well it works under heavy load. And then there's security testing. So instead of doing testing after the fact, you build in security testing into your CI/CD pipeline. The cool thing about AWS is you get charged by the second for EC2. But let's go up to the hour here. But it costs the same amount of money to have one instance running for 100 hours or 100 instances for 1 hour. So if you need to do a big load test and you need a lot of resources spun up to generate the load needed by that test, it's not gonna, as long as you shut your resources down as soon as you're done, it's not going to cost you a lot of money. So it's to your advantage to do things in parallel when you can. So for example, let's take a look at a pattern with A/B testing. So in this example, we've got 2 copies of our app. So we've got 2 auto-scaling groups. One auto-scaling group has 1 copy of the app, and the other auto-scaling group has a second, slightly different copy of the app. And then we use the load balancer to divide traffic among them. And so you can actually split the traffic across them and see, okay, well, for this feature that I'm testing 2 versions of it, which performs better, or which do my customers like better? So you can do A/B testing like that. And we have a blog post on it. So if you want to find out more, take a look at, search for weighted round robin Route 53 ELB integration. For load testing, again, you can quickly spin up hundreds or thousands of instances, and you can load test your own application with them, and you can shut them down. There's also a lot of third-party frameworks for doing load tests, which I've seen customers use. And there's actually, if you search on YouTube from a previous reInvent, there's a talk on, or probably several talks on how to do load testing on AWS if you want to find out more about that. And also, on AWS, you have CloudWatch. So CloudWatch is our metrics and logging service, and so you get metrics such as CPU usage. So while you're doing the load test, you can actually see, well, how does my infrastructure react to this load test? So you can see how the CPU usage rises, what parts of your infrastructure get stressed, and so you can use those lessons to learn what do I need to scale, what are the, if any, are the single points of failure in my infrastructure, and so on and so forth. And on our marketplace, there's a bunch of load testing tools that you can quickly get up and running as well if you don't want to set up on your own. Now let's talk about our code services. So just a brief overview. So we have a whole suite of code services now. We have Code Pipeline, which basically handles continuous delivery and transitions between, for example, your source phase, build phase, test phase, and production phase of your software development lifecycle. We have Code Commit, which is a managed Git service. We have Code Build, which is a managed building and testing service. And then we have Code Deploy, which is a service that you can use to deploy your code onto instances. And then we have CodeStar. So CodeStar is a service that we have that quickly provisions some combination of these services for you and gets a application environment spun up for you very quickly. So just to quick summary of Code Build. So again, you can do this manually with something like Jenkins, but what Code Build does is you pay by the minute for it. It is run in the background on Docker containers. You can either use one of our pre-built build environments or bring your own Docker image to have a custom build environment. It scales continuously and processes multiple builds concurrently, so it takes advantage of basically parallel computing, and is a fully managed service. So you just give it the code, you give it a file that tells it how to test the code, it spins up a container, it runs the test, it tells you whether it passed or failed, and then gives you the output in CloudWatch logs, so you can see what happened. And it integrates with Jenkins and Code Pipeline, so you can probably integrate it with your existing CI/CD process. And again, CodeStar allows you to start developing an AWS in minutes. It handles managing your team members. So if you have multiple developers working on the same project, you can manage their access to those projects using CodeStar, and you can choose from a variety of project templates. So let me do a quick demo here of CodeStar. So let's see here. So here's the CodeStar UI. Hold on. There we go. So I'm going to create a new project. So again, I have different templates that I can choose from. So Ruby, Java, Node, Python, ASP.NET, a lot of choices here. So I'm going to choose let's choose a PHP project here. And for PHP, I have different options, right? So I can do Elastic Beanstalk, I can do EC2. So I'm going to do Elastic Beanstalk. So I'm going to let's do demo PHP EB project. And it asks me what repository I want to use. So if I have my code already in GitHub, I can pick that. If I have my code in AWS Code Commit, I'll pick that. So I'm going to pick Code Commit here. And so it's going to choose to use Code Commit, Elastic Beanstalk, and CloudWatch. And if you chose one of the other templates, it could use a different combination of services. So I'm going to go ahead and create the project. So it's going to ask me which key pair to use. So I'm just going to pick my key pair. And then it lets me integrate with my either CLI tools or Eclipse or Visual Studio. So you can do different IDs that integrate with CodeStar. So I'm going to actually skip that for now. And so it's provisioning, but let's take a look at one that's already provisioned. So I'm going to create another project here a few minutes ago. So this is a similar kind of project. And so I can do several things here. So it gives me access to my repo. So here's my code commit repo for this. So this is where all the code for my project is. And it gives me access to the endpoint for the project. So this is the actual endpoint. This is my actual application here. And this is my code pipeline. So anytime I release a change in code, so let's say I'm going to manually do this, but let's say I updated my code in code commit, it's actually going to take the code and it's going to deploy it again with my Elastic Beanstalk project. I also have access to a wiki tile, so here I can, it's an open-ended tile, so I can keep track of like a to-do list or notes for my team members or whatever else I want to put on there. And then this is my commit history, so this is the history of commits against the Git repo that this is tied to. And here's some CloudWatch data. So this shows me the CPU usage of my application. So I just spun it up for this webinar, so it doesn't have much yet. And I can also connect this to Jira. So if I have a Jira running, I can connect it here, and it would show my Jira issues as well. Another thing I can do here is actually manage my team. So right now it's just me, but if I wanted to add a team member, I can do that. I can give them different roles. So I can pick from an existing IAM user that I have, or I can create a new one. I can give them remote access. So if I, for example, were to add my SSH key for myself, it would give me SSH access into my instances. They're spun up as a part of this project. And all of this in the background is, by the way, is done by a CloudFormation template. So I can take a look at the template, and it's pretty easy. If I want to delete this project, since it's dev and test, I here delete project, and everything that I spun up would get deleted pretty quickly. So that's a really simple demo of CodeStar. So let's go through a summary here. So AWS makes development and testing far easier. Because of the elasticity of AWS, you can take significant cost savings because you can expand your environments when you need to, you can shrink them when you don't, and you can shut them down when you're done. AWS gives you a lot of unique tools to allow you to manage and create your environments, and they're all flexible, so you can either run everything on EC2, you can use something like Elastic Beanstalk or Code Deploy, so it just depends on your requirements there. And you can operate at scale and speed beyond traditional infrastructure. I can go from not having an AWS account to running a large footprint in minutes, and that's something that is much harder to do in a traditional infrastructure. So let's just talk about some resources you can use to learn more. Well, if you go to aws.amazon.com/dev-test, you can find out more resources on there, CloudFormation templates, documentation, so on and so forth. And we also have self-paced labs online, so you can go online and do some self-paced labs to try these services out for yourself. We have various kinds of training, so one-day trainings, three-day trainings that you can use to ramp up your AWS skills. And after you've done that, you can go and get certified. So we have different certifications. For example, you can become a certified solutions architect at 2 different levels. We have a DevOps certification and others as well. And so that is what I have for you for today. So thank you for coming to the Dev and Test on the AWS webinar. Thanks for your time.